So in this video I'm going to detail a little bit of a gotcha, or perhaps something that's not intuitive but it's very useful to know if doing any work with unlit shaders in Unity. It's just kind of bitten me and I thought I'd just document it just to save anyone else any hassle. And the issue is this: what I've got is the output from Unity object to clip paths, which you'd expect to be the clip space position of the vertex. Well, it is the clip space position of the vertex, but what I was expecting is that when you get into the fragment shader, I'd be able to just access this, and this would now be the clip space position of the pixel, but that isn't actually the case. And to demonstrate this, so you don't have to just believe me, I've created a second field with the same type, and I've copied the value returned from this into this other field. So now we're just going to see that if we actually, from the pixel shader, return the XY, display the X, Y, and Z components of this vector as colors, we'll see we get pure yellow in this case, and if we use the other field we get completely different values. And if in fact, if you know stuff about clip space, you'll recognize these and what these colors kind of represent. You'll recognize that this is what you should be getting from clip space values. So what's this other thing? What's going on with this? Well, first of all, most importantly, I guess it's just the conclusion is that if you do want to use clip space X and Y, I think Z values might be alright, but especially if you want to use X and Y values, you can't just use the actual vertex value that's passed through all the way, because it is modified, and it turns out that the X and Y values are actually pixel coordinates on the screen. So if we display vertex as X as red, you see we just get solid red, and that actually indicates that the values are above 1. Now if you divide that by 800, you'll get a nice smooth. Now I say if you divide it, but I mean in my case, when I divide it I get this because the screen resolution here is set to 800 by 600. So this implies that before the division by 800, the values here of X were actually 0 to 800, and similarly the same is true of Y. Now the same is not true of Z actually, so the Z values are actually seem to be normalized depth between the near and far plane. So for example, because I want to use my movable pillar, so let's just do this. So I'll just set the blue values to the vertex Z and we get this, and then if I slide this pillar inwards, you can see we get the nice value here. Now let's just use clippos.z, and it looks like we get slightly different values, and I believe the reason is, well, these values are okay, let's divide by 5. I'm not actually sure, I haven't properly investigated this, but I think it might be that the values, what I'm going to do is subtract 1 so we can see if there are any values over 1. If everything's black, yes, okay, so we have some values that's greater than 1. I kind of wasn't really expecting there. I guess this might actually be distance. Oh, of course, I forgot. Okay, the actual clip space, you got to do the perspective divide. So you got to divide by W. Silly me, forgot that. So if you want to get the actual proper values, now we've got the proper values. So it looks like our values are actually the same in the other field. It looks like the blue is exactly the same. Okay, well that concludes that. So you can use the Z values as clips, but it looks like you can use the i.vertex.z as clip space Z, which will be depth, normalized depth. But the X and Y values are actually screen coordinates, pixel coordinates. So if you want the actual X and Y vertex clip space stuff for some reason, then you're going to have to save it away. Anyway, got a bit diverted there, but hopefully that was that'll be somewhat useful to somebody. Well, that's it. So thank you for watching and goodbye.